Problem 4. X is equal to 2 cosines of t, y is equal to 4 sines of t. When graphing parametric equations that contain the sine and cosine, it's a good idea to consider the period of those functions, which is from 0 to 2 pi. Now, if you're using a TI-83 or 84, if you press Zoom Standard, it'll automatically give you that window, so it's kind of convenient. Fill in your table if you need to, and eliminating the parameters is a little tricky. The one way of doing it is to take your pieces, x is equal to 2 cosines of t, y is equal to 4 sines of t, and square both sides. So x is equal to 2 cosines of t turns into x squared is equal to 4 cosine squares of t. Divide by 4, and you'll have x squared over 4 is equal to cosine squared of t. Y is equal to 4 sines of t turns into y squared is equal to 16 sine squared of t, which dividing by 16 gives you y squared over 16 is equal to sine squared of t. Adding those two together, you get x squared over 4 plus y squared over 16 is equal to sine squared plus cosine squared. But from trig, we certainly know that that's equal to 1. So we arrive at the equation for an ellipse, x squared over 4 plus y squared over 16 is equal to 1. Now the 4, if you take the square root, you get 2. That is called the semi-minor axis of the ellipse. Take the square root of 16, you get 4. That's the semi-major axis of the ellipse. So we could graph that, starting off at the origin, go 2 to the right, 2 to the left, 4 up and 4 down, and make an ellipse. Now another way of doing this is once you see the graph is an ellipse, is remember from your conic sections days that the equation for all ellipses centered at the origin is x squared over a squared, which again is that semi-minor axis, and plus y squared over b squared, which again is that semi-major axis, and you can then write the equation pretty quickly. And always make sure that you check the orientation of the graph, because again these represent movement, which is very valuable when you hit Calc 3 and have to be talking about vectors. And problem 5, very similar, except now those numbers in front of the cosine and sine match up perfectly, so we should get a perfect ellipse, which of course is a circle. And again, building a table, squaring those pieces if you'd like, or just remembering from your conic section work in college algebra that the equation for all circles centered at the origin is x squared plus y squared equals r squared. Draw your circle with a radius of 4, and again pay attention to your orientation as you see it graph. And problem 6, by reversing the sine and cosine, of course you're still going to get a circle, but notice the orientation for this compared to problem 5. It reverses the orientation where this is going clockwise, where problem 5 was going counterclockwise.